Alright, what we're going to look at today is arc, sectors, and segments of circle. What I'm going to do is make sure that you understand what arc, sector, chord, and segment mean. Alright, you need to know what is minor and major, arc, sector, and chord. Of course, you do know things like radius, diameter, and circumference. I'll go through all of that again. And then we need to think about derive and use the rules to calculate the length of an arc, area of a sector, and area of a segment. Now, all this, the formulas are given in formula sheet, but I need to show you how to derive it. Alright? So this time, what we're going to look at is, we've done a lot in terms of degrees. This time we're going to look at radians. Radians is important. Now, first thing that we need to know is just some features of a circle. These are all the terms that you need to know, and each slide that I have will have different color. Like for example, radius. This is the radius. This is the diameter, you should know that. Circumference is just the whole of this circle. Alright? Chord. It's just that. That is the chord. Chord actually touches the circumference of the circle only, and is within the circle. Alright? Now that's different from secant. I'll show you what the difference between secant and chord is. Tangent, it touches the circle once, and it's perpendicular to the radius. Perpendicular to the radius. Alright? And then secant. Secant is actually just a straight line cutting through the circles. It actually will go from one side to the other side. It cuts through the whole circle. Chord is within the circle. That's the difference between the chord and the secant. Alright? Next, we talk about minor and major arc. Major and minor. What you need to think about is look at the angle. So this one will be the minor arc, whereas this big thing will be the major arc. Alright? This is the major arc. And this is the minor. Alright? Look at the angle. The smaller angle is the minor. Just like this is the minor sector, whereas this is the major sector. That's the difference. Major and minor is just between the angle, that's it. Then you need to know what is the major segment and minor segment. Minor segment is just this bit. The chord separates the circle into two parts. Minor segment is the smaller part, and the major is the larger part. Alright? Now, what we need to do is be able to find the length of the arc. Sector and area of sector and area of segment. Let's start off with arc length in degrees. Alright? Now, you know if we look at the arc length L, the subtend angle of theta, that bit here. At the center of a circle is a proportion, it is actually this bit, L. It's a proportion of that, the whole circumference. Is that right? That is basically given by theta over 360 degrees, if it is in degrees, times 2 pi r. Now, can I actually change that if the angle is given in radians? What happens when the angle is given in radians? What is 360 in radians? 2 pi. So if we substitute 2 pi in, alright, we know substitute 360 as 2 pi. What happened there? If 2 pi is there, can we then cancel off the 2 pi? So if the angle is given in radians, L, the arc length, is just radius times the angle. That's it. Angle in radians. So the reason why we don't have to worry about the 2 pi now, the pi is taken into account when it's converted to radians. Right? You don't have to think about the pi now. You're thinking about radians. Radians measure, you've taken the pi into account. So therefore, it's just arc times theta will give you the length of the arc. Alright. make sure that you know the difference between the minor and major arc. Alright? Of course, you can work out the minor first and work out the circumference and take away the minor arc to find the length of the major arc, or work on the angle. Take away the angle and use this angle to find the length of the major arc. Alright, examples. Now, calculate the arc length of a circle with radius of 10 centimeter subtended by an angle of 3 pi over 4. So, now, maybe it's worthwhile drawing a circle, sketching a circle. You know this is 3 pi over 4. Alright, and this is 10 centimeter. So therefore the arc length L equals to 10 times 3 pi over 4, which is 15 pi over 2. Now, if there's no, and make sure that's centimeter. If it is in a count-free section, you will give the exact value, or in terms of pi, values in terms of pi. If not, decimal places, I've worked it out to be 23.56 centimeter. Make sure that you read the question carefully, whether you are asked to give it in decimal places or asked to give it in exact values. So that would be 2 decimal places. You could, well, if the question did not specify 1 or 2 decimal places, you could even give 33.6 and just put down 1 decimal place. Generally, we will specify. Alright, that's arc length. Arc times theta. And theta, yep.
It doesn't say to like put in 2 decimal places.
Yeah, I didn't say, but that's why I'm giving you the 2 answer. That's why I'm giving you the 2 answer. Examples. I'm just pointing out very clearly to you what exact values and the decimal place.
In a 10, could you just put it as exact?
Yep. Yeah. If it is count free, you have to put it at exact. Yep. Count free, just put it at exact. No, we don't expect you to work it out as decimal. Alright? Now, area of a sector in degrees first. Again, it's the same. You can work out pi r squared. And then, of course, you can work out that bit here, the sector, is theta over 360. It's the proportion of the area. Again, we can substitute 360 as 2 pi. Correct? So if I can substitute 360 as 2 pi, what happened there? I actually can eliminate the pi. Pi divided by pi is 1. Correct? So therefore, with the angle, if the angle is radians, it's actually the area of the sector is half r squared theta. That's all. Alright? Makes life a little bit simpler in that case. You don't have to use fraction, not theta over 360 degrees. So remember, in radians, it's half r squared theta. That's all. Now to example number 2. Calculate the area of a major sector of a circle with radius of 9 centimeter subtended by an angle of 5 pi over 3 radians. So, you know that one of the angles is 5 pi over 3. The other angle is, what would the other angle be? If one is 5 pi over 3, the other one would be? Sorry? Beg your pardon?
Pi over 3.
Pi over 3. I don't know, you tell me. So, if it is 2 pi minus 5 pi over 3, what is it? Pi over 3, thank you. So you do know that this is the angle that you're looking at. 5 pi over 3. Alright, the other one is pi over 3. So it's a major sector, you now know, and this is 9 centimeter. So area equals to half times 9 times 9 times 5 pi over 3, which is 135 pi over 2, because you can get rid of that. This is exact value, and therefore that equals to approximately 212.08 centimeters square. Alright? So So see the difference between exact values or in terms of pi, and the other one is decimal places, 2 decimal places. Finally, the last one. The last one is area of a segment in degrees. So we are going to look at just this area. Alright? Now, you do know that in this case, we've got the area of a sector and also area of the triangle, correct? You can work out the area of the triangle as half AB sine theta. Agreed? You know R and R, both of them are the same. So, area of the segment is area of the sector minus area of triangle. And therefore, knowing these two, area of the sector is theta over 360 degrees times pi r squared in degrees. And area of the triangle is half AB sine theta. Alright, half AB sine theta. Therefore, area of the segment is pi over 360 degrees. Sorry, not pi, theta over 360 degrees times pi r squared minus half r squared sine theta. Do you all agree with me? Yeah? Alright. Now, again, how are we going to change it when it is radians? Which terms will it affect? This or this term? Which term will it affect if I change it to radians?
The degree one.
The degree one, it will affect this, but this, as long as you input that as radian, that's fine. Alright? Yeah? So, now, rearranging this, I can take the r squared out. I just want to work with the angle first. R squared, both of them has r squared, I factorize the r squared out. So now in radians, the reason I want to do this, the reason I want to do this is because I want to make life a little bit more difficult when I just go with the angle. R squared is out, we don't have to worry about the r squared. Alright? You don't really have to worry about writing this down. You will get it in the lesson slide anyway. The most important thing is the next one. In radians. Now, if I substitute that as 2 pi, what does that happen? So we now have area of the segment is r squared into theta over 2 pi minus half sine theta. Right. Can I get rid of the pi?
Yeah.
And then, can I factorize the half out?
Yeah.
Theta over 2 half. So therefore, rewriting it is half r squared theta minus sine theta. Again, this is in radian, this is in radians. So what happened is, radians you have taken into account pi. Alright? Sine theta, you are inputting that value as radians. So, area of segment is half r squared theta minus sine theta. And of course, this is the minor segment. Alright? If you're talking about the major segment, it's just the whole area, take away that small segment, correct?
Yeah.
Yeah? Good. Last example. A chord in a circle of radius 9 cm is subtended by the angle of 2 pi over 9. Calculate the area of minor segment formed by the chord. Minor. So if I draw that, this is 2 pi over 9. And this is 9 centimeter. And you want this area here. So therefore, area equals to half 9 times 9, 2 pi over 9 minus sine 2 pi over 9. Now, in this situation, it has to be calculated assumed. It's very hard to get the exact value unless this is 60, 30, or 120 or 45 degrees and so on and so forth. Alright, if it is the multiples of pi over 6 and pi over 4, it will make life a little bit easier. If not, no exact value is 2.24 centimeter square. Alright? So you could use your calculator and not worried about exact values unless you are given something that you can find the exact value. Alright, that's all I have for you today. Oh, actually before that, this is a summary. Everything in radians will be given in this formula sheet. Degrees, assume that all of you know how to do it. It's just a proportion. Theta over 360 degrees. That's all. Alright, this is all the lesson for today.